All right, welcome everybody. So please turn to your exponential growth and decay worksheet. That should be the very first set of notes, and you're going to fill in just like if I was in the classroom. So this unit, last unit, we spent going over radicals and exponents and how to kind of like just operations, simplify them, some of their properties. This unit's going to be on writing their equations and their graphs. So we're going to start off with exponential growth. Your growth function is kind of broken down, as you can see right here. The f of x, that's just your basic amount, your total amount, whatever it's looking for when we're looking for that. This a value, if you have a number out in front, if you don't, it's 1. If you do, that is your initial amount. You spent $3,000 on a car, or you deposited $5,000 in a checking. So it's the very starting amount that you have here. This entire equation, the 1 plus the, well, let's start with the r. The r is actually your percent. So you will convert whatever percent, that rate, into a decimal form. So you want to make sure you remember how to convert back and forth from decimals. And then the 1 plus the r, which is that number, is called the actual growth factor. So again, you're going to hear the word factor. If you see that, it's not asking you to factor this growth factor, whatever this is that equation, right? And then finally, t is going to represent time. Usually put x if you're graphing it so that you have an x and a y part. All right, so let's go ahead and just take a look at the growth functions, and then we'll go into the decay functions. So as you can see, we're not going to get too far into the graphing. I'm going to do one graphing, and then after that, we will, we'll kind of let you guys graph that on your own. Give me 1 second. Okay, so you will want to have your calculators because, again, when we get to the graphing part, you're going to be filling in, and we're just going to do a basic t-chart. You get the idea of it from there. All right, so we're to fill out this initial box here that we want to know. We want to know the initial amount. Remember, that is the a value. That was that number that's right out in front of that parentheses. So that would be our initial amount. In this case, it was 4. Our rate of growth, when we see that word rate, that means that we do want the parentheses and decimal. I'd like to see that you know both of those. So I can do this. So parentheses and decimals for that. And then the factor will be what happens when we add 1 plus what we get from that. So I can see here my rate of growth is the 15 or the 0.15. To get that as a percent, I just move that decimal spot 2 to the right, and that means that I have a 15% growth on this equation. My growth factor is when I actually add this together. So I go 1 plus the 0.15 gives me 1.15. So easy enough. It shouldn't take too much, especially you honors kids. And then we turn around and it says f of 2. Well, this is saying if I was at 2, where would this function be? Well, that would just be me plugging in 2 into this equation. So in our calculators, we're going to plug in, the 2 for the x right up at the top. And so I'm going to take just a second to type mine into my calculator. You should as well. It should look exactly like you see, so 4 parentheses. You can go ahead and add that. That's 1.15. And then remember that it's the caret symbol to get up to 2, that little kind of arrow thing. And I got 5.29. So this is 5.29. So I have this. All right. So you should know the basic shape of exponents. We went through all of those. Your growth one should be shaped like this, going up, and then kind of going down like this, it'll come to an asymptote. So I know that when I go to 2 over here and 5.29, I'm going to put a little dot right here. That's what we just found. I'm going to plug in a couple other dots just so I can graph this. And then, as I said, this will be the only one I graph. You guys can graph the rest in your notes. Let's go ahead, always take a look at what's happening at the y-intercept. So we're going to plug in 0. So once again, I have that equation, and I can simplify that to 1.15, and I plug in 0. This, you shouldn't have to use a calculator. Anything with the 0th power turns into 1. So that's 4 times 1, which is just 4. So again, as you can see, we're starting, that a value has us starting at 4 right there. All right. Going to some other numbers, so I can kind of see I'm getting a graph that kind of looks like this. I can see that this other part's going to go up like that. I kind of want to see if there's an asymptote, and at this point you guys don't know what it is, so I'm going to check to see if it's going to go all the way down to 0, will it go past 0, that kind of stuff. So I'm going to choose some numbers off to the left hand side here. I'm going to first start by -5, kind of move us down pretty far. And again, I'm just going to type all of that in, the -5 exponent, and get my answer. Remember, you can always do that copying thing that I showed you. And that gives me 1.98, or close to 2. So I'll go here. It's really close to 2. It's right around here. Let's go ahead and plug in that -10. Let's see what happens at the very end of my graph. Did we go past it? And then I'm going to choose a number that is crazy out there, like, I don't know, 1,000 or something, just to see how close I can get. Gives me an idea of where my asymptote is. So when I do -10, I'm at 0.98. So I'm close to 1, but I've actually gone below 1, which does help out. So I know my asymptote isn't 1. On this graph, it's just going to be connected like this. But I do need to find that asymptote. So I'm going to choose, as I said, a ridiculous number over here. Let's just do 1,000. Let's see where that kind of leads. So I go up to my calculator once again, and I put in 1,000 this time for the x value. Sorry, not 1,000, -1,000. And if you look at it, you're going to see a number, at least my calculator is giving me 8.02, but then it says e to the -16 if you see that. So I'm going to write it up here, what I see on my calculator, so you can kind of see what it's doing, and then I'll talk to you this. And it has this whole number, it has a bunch of other numbers, but then at the very, very end, it says e to the -61. And what that means is that it has gone so far out, that this decimal has gone so far out, it can't actually put it there. There's so many zeros here, about 61, before you even get to the numbers. So there's just a ton of zeros between here and here. And that tells me I'm getting really, really, really close to the number 0. I'm always going to be, remember, he's never going to touch it, but he's going to get close to it. So that means my asymptote is right here at the y equals 0. So I put my dotted line. That's what he's going to get really close to, as you can see, but he's never going to actually touch it. So that's kind of the growth one. You guys have one to practice. And then when I get back in, well, actually, let's do this one. As I said, you guys can do the graph, fill that in. This is still a growth one. So our growth equations, just remember when you're graphing them, should look kind of going up like that. And they will have an asymptote that you will need to find. If I go here, just to fill in this box, so I'm going to do for right now, the 1/2 is my initial amount. Come over here. And in this case, I don't have my percentage. I have 1.95. That is the factor. Notice there's no adding or subtracting going on, which means they already did it for me. That's 1.195. So to get to the growth rate, I have to take the equation, the 1 plus r. That's how they got that factor. And I'm going to make it equal to what they have and then solve it. Now, growth is usually pretty easy. Most people can figure out that percentage quicker. But if you practice this way, it will help you when you get to decay, which can kind of throw people off. So my rate is 0.95, which is 95%. So I have a growth factor of 95%. It does say plug in 1, just to see if you can find a value. So again, I would just type that into the calculator. With calculators, it will help to put parentheses around that 1/2 and parentheses 1.95 to the -1. So type that into our calculator. Sorry. 25 gives us 0.256. So you have one of your points. You have -1 and then 2.56, which is right around here. So, and then you can figure out where the other one is. All right. And I want you to notice this is going to go a little bit different than you think it should, because even though it's a growth factor, that initial starting at 1/2 is going to cause a little bit of an issue. So, if I go there, all right, sorry. Well, let's get into decay. So notice the equation looks almost the same. This again is going to be our total amount off to the side. That's, our y values when we're plotting them. Up here, this is still our initial amount. This still represents time. This is going to be a factor, but it's going to be the decay factor now because it's going down. That's why it's subtraction. And that's still the rate, and we will still convert it into a decimal. So all of that stuff kind of stays the same. All right, so let's get to one of these. So again, I will let you guys do the graphs, right? Normally decay means it's heading down, but that can change based on other factors that are going on. So that's your general change. So we're going to start off. Our initial amount here is 4. Sorry, it says growth. These should say decay. Both of these. All right. So our rate of decay is that 0.15 or 15%. So you want to make sure you can move the decimal the right way. And then, of course, you could go into a calculator. If you know what it is, you just actually do the subtraction. So the 1 minus 0.15 gives us 0.85 as the actual factor. And then in the calculator, you just type in 4.85 to the 2 is what they want this time. So typing that in gives us 2.89. So that's kind of finding that. As I said, kind of moving along. Again, you would come in here, you'd put in a bunch of values ranging from these domain numbers and then plot your points at this point. We will go into graphing and I'll give you guys some shortcuts, but right now I want you practicing T-charts. All right, last one like this, and then we're going to go to story problems. So again, initial value, 1/2. So I'm starting at 1/2. This is decay. Sorry, it doesn't say that, it should. I believe in your notes it does. I corrected it there, but I did not get time to correct it on my slide. So just be aware of that. This time, notice there's no plus or minus sign. That means that they gave me the factor. So I can come here and say, okay, well, they gave me this factor. And then I have to come up here and say, if I want the actual rate or percentage, I have to do the 1 minus r equals, and then I have to give the actual growth factor on the other side. Because when I subtracted it, that's what it equals. Solving this, we would subtract the 1. And again, you guys do get scientific calculators, so you can always, just type in the numbers in your calculators. I would always double check, especially while we're dealing with exponentials. So that gives me negative. Don't freak out, it's negative. It's negative because notice the r is negative. All right, so it's negative 0.5 or 95. To get rid of that negative, I would divide by a negative or a -1. That's really what the number is. And notice it's going to flip to a positive. So you don't really need to worry about it being negative because it's going to flip because of that r. So we have a growth rate of decay, at 0.95, which is a 95% decay. So it's going down really, really, really fast. All right, so we have 1/2, we have our 0.05, and then we're putting it to the -1. Plug that into a calculator, and then that will give you your value at -1. Sorry, get my caret symbol, and I got it at 10. So -1 is at 10, all the way up here. So definitely graph these, because even though we should see decay going down like that, you always want to double check just to make sure it does. And also take note of where that y-intercept is. And looking at the equation, how could you find the y-intercept in your mind? How could you find it without having to do calculations? All right, let's move to story problems. That's the last bit in your notes. I like exponentials in this way because to me, they're kind of easier story problems than even arithmetic. All right, so starting off, the world population in the year 2000 was approximately 6.08 billion people. The annual rate of increase was about 1.26%. So again, a couple key things I see here. I see that as a percent. That means they gave me the rate, they didn't give me the factor. So just keep that in mind. And then I also see another set of numbers here, the 6.08 billion. This is my initial amount. I am starting in the year 2000 with 6.08 billion people just sitting hanging out on the planet, right? It asks, is this growth or decay? So if I look up at this, I have an annual rate of increase. Well, increase means this is growth. We are not going down in population, it is going up, right? What would be the rate? As I said, they gave us the rate because that's a percent. So I know it's 1.26%, And I always want to convert that to a decimal because I'm going to have to deal with the factor usually shortly after. So to move this to a decimal, to go the other way, you go this way, right? So that gives me 0.0126 is my decimal version of 1.26. Then it goes, what is the decay or growth factor? Now I'm switching into that factor where I use that equation of 1 plus R, and we know that R was the 0.126. So my growth factor would be 1.0126. That's what that one is. And then write equation. Well, all of this built up to writing that equation. So we turn around and say, okay, well, y equals my initial amount, which is the 6.08. Inside, we put our factor, our growth factor, which was 1.0126. We say it's to t, or because it's equation, we're going to use x and y. We'll use x. So there's our equation. And all of that brought us to this. Let x be the number of years past the year 2000. What would be the population in 2010? Well, 2010 is 10 years after. So if I wanted to figure this out, I would plug in the 10 years for x, type it into the calculator, and it will give me a rough estimate. Now, the nice thing is we don't have to type in billions. They've already kind of gotten it, so hopefully we won't have to see that wonderful little e. So I have roughly 6.89 billion people. So again, remember that A is your initial amount. Inside, you should have it simplified to its factor, but it will always usually lead you there just so we can know that you can go back and forth with the growth rate. All right, last one to try to double check, and then you guys can get onto your homework. So a computer, you bought a computer, it depreciates, well, you bought a computer at 6,500. It depreciates at a rate of 13.3. Again, I always like to say, okay, I see that percentage, so I know that I'm going to have to convert it into its decimal form. This is what I first initially bought the computer at. That's my A value. There's my R if you want to write that out. And then depreciate. Well, depreciate means goes down, so that is a decay function. Right? It is asking us to go directly to writing the factor. So because it's decay, our factor is 1 minus R, and then I would plug in the R value as his decimal version. So the decimal version here would be 0.143, and then I would actually do that math. So I turn around and just get out my calculator, 1 minus 0.143, and that gives me 0.857. Again, I type that into the calculator. Don't do it in your head. All right, that's its factor. Now it wants me to write a function. That's basically saying write an equation. So I'm going to turn around here and say, okay, y equals my initial starting value of 6,500. Inside should be my factor. That's the 0.857, and then to the x power. And then again, he asked, what would be the value of my computer after 3 years? So I would just type in this into the calculator, put it to 3 years, and I should have, sorry, getting it up there, my value, which is roughly, remember it is a dollar amount, so we have $4,091.25 is what my computer will be worth. All right, so hopefully this helps. When I come back, we're going to be moving to the next lesson. I wish I could have been there to teach it for you, but again, please get this done and then work on the homework. I believe it is a worksheet, so just get that from the sub. Thanks.